Good day, guys. Alright, so in this video, I want to talk about potential dividers. They have numerous applications. One of the most basic of it is, those house lights that you can make it dimmer or brighter by just turning a knob. Those work on potential dividers, on the principles of potential dividers. They affect or they change the potential that they supply to the light bulb. That is one example, right? So let's look at the most basic of potential dividers. Say you have a voltage supply. So here's your voltage supply. We have V in, right? And then say you connect it to two resistors. So this is R1 and then this is R2. Okay. So let's just say that. And then let's have the positive terminal here, the negative terminal here. Your current will be moving clockwise. And then what you do after that is that you connect um, just between R1 and R2, and just before R2, just before after R2, you connect that to an output. I'm going to call that V output. Okay, so this is going to be positive and this is going to be negative. Okay, so now we look at the circuitry, and then we ask ourselves, okay, can I apply Ohm's law, because we are talking about resistors and we assume that these resistors are ohmic. So what we have is Vi is equals to I times R1 plus R2, and this is just from Ohm's law and the fact that R1 and R2 are in series. All right, so we can then ask ourselves, what is the voltage across R2? Because the voltage across R2 is going to be the same as the voltage across sorry, the output voltage. Okay, and that is equal to I times R2. Okay, so I'm just gonna call this I, and then this is I2. If we rearrange those two equations so that we have only current, we have it as a function of current. So II equals to Vi over R1 plus R2. And then the second one gives you I2 equals to V out over R2. I2 equals to V out over R2. We have to ask the question, are these two the same? Well, they are, because this circuit or the pair resistors are in series. So we can equate those two. So I can put Vi over R1 plus R2 is equal to V out over R2. Now if I rearrange that, right, so that I have V out on the left side, I can have on my right hand side R2 over R1 plus R2, and then that multiplies with V in. Okay, then of course a more generalized case, right, a more generalized case would be R2 over R1, then add all together all the way to Rn, the summation of them, right? Vi. All right. Okay, so but this is a bit annoying because then you have to change R2 every time you want to change the light bulb. I mean, you want to change the brightness of the light bulb. So what do you do? Well, what you can do is modify this circuit. So let me just change colors. Modify this circuit. So here's plus, here's minus. You can modify this circuit such that, so let me just draw the V out, V out. Okay. You can modify so that you have instead wires. So I have wires there. So this is a wire. Okay. And you can have pointers that you can slide along left or right, or up and down in this picture. When you slide it up and down, what you do is that you are changing the length here. So I'll call this L2. Then that would obviously mean that this is L1. Right? When you change, you increase the L2, right? You increase the L2. What happens is you also change the resistance, and that leads to a change in the output voltage, right? So in the end, what we can talk about is again Vi. You have V out is equals to R2 over R1 plus R2. If we refer back to our equation on the previous slide, you will have this. But because now you know that R is equals to rho L over A, and if the whole wire is made of the same material, then you have rho to be the same for both L1 and L2. And then you have A, if the cross-section area for the whole wire is the same, then it has the same cross-sectional area. So then if you just substitute it in, you know that V out would equal to L2 over L1 plus L2, or the total length, times Vi. Okay, so this gives you the flexibility to adjust the amount of voltage rather than going through with just changing the resistors. All right, so those are the two equations that you need to know, or at least you should know, from this particular topic, the potential divider. It divides our potential so that you can control your output voltage. That is all. I'll see you in the next video.